Okay, so this question is also on complex numbers, and I've got to plot the complex number z equals 4 plus 3i on an Argand diagram. And so let's bring that up. Now, the way to plot these diagrams is that you put the value that is not imaginary as x, so that'll be 4, and the value that is imaginary on the y-axis. So this is the y-axis, this is the x-axis. Okay, so let me get a better color. Now, the diagram is quite straightforward. It's just a line from the origin to the plotted point. So 4x, 3i. So the line goes from there to there. And this is part of our diagram. Now, this is our radius. And now on this side is our angle theta. And we put z equals to 4 plus 3i. So remember, we put the imaginary at y and the real at x. Now for part I, we have to determine this for z, the modulus r and argument theta. And to do this, we gotta find the modulus first. The modulus r is given by the square root of a squared plus b squared on the z a plus ib. So for this equation, to get the modulus r, we do this. So this will be 4 squared plus 3 squared. So square root of 4 squared plus 3 squared. And the inside will be 16 plus 9, which will be square root of 25, which will be equal to 5. And now to find the argument theta, we have to do the tan theta. So argument theta will always be tan theta equal to b over a. So to do this, we gotta put tan theta is equals to 3. So the imaginary is always at the top. So 3 over 4, and the answer would be theta equal to negative tan 3/4. Now you could calculate this, but it's not needed. It's only asking for an argument, and this is a valid answer. You could also put arctan. You could also put arctan, and that will be a correct answer as well. We also have to write z in the polar form, and if you guys did not know, polar form is z equal to r c I s theta. That is the polar form. So what's the form then? The c over here means cos, and the s means sine x. The I is imaginary, so we have found r before, which we came up to be 5. So r, so let's put this values. R equals to 5. Z will be equal to 5 cos plus I sine cos theta sine theta. So theta is tan minus 1/3, which if you put it in your calculator you get 36.87 to 2 decimal places. So your new equation will be 5 cos 36.87, which if you put in your calculator will give you 4/5 plus I sine that value there, which will give you 3/5. So 3/5. So this will also be 5. This is also 5. So 5I 3/5. So eliminating 5, so we get 4 plus 3I. And that is the answer we got in the first place. Now part 2, I using the results from I, write down the exponential form of z and use this to write down z squared, also in exponential form. Okay, so the results we got from I, which were r equals to 5, theta equals to inverse tan of 3/4. So this is the values we got. We got r equals 5, theta equals. Now the exponential form is z equals to r exponential I theta. So we just gotta put these values into it. So z will be equal to 5 exponential, let's put it in degrees, 36.87 I, and that is the value that we get for the exponential form of z. Now we gotta do z2 in exponential form. We just gotta remember this formula, that z to the power of n equals to r to the power of n e to the power of I n theta. So the value here is going to be double, and r is going to be to the power of 2. So it's 25, and e is going to be times by 2. So this will be 73.74 I. And that's it for this question. Welcome to the last question of this paper, which is also a very easy question, considering that I is a constant in this particular equation. So y equals to cos x plus I sine x. Now we gotta know this. So y cos x, when it's differentiated, we always get minus sine x. When y is sine x and we differentiate it, we get cos x. So after you knowing this, it should be pretty simple. So dy by dx is simply going to be minus sine x plus, you just put a I, cos x, because the I is a constant, so it stays there. And that's it, we concluded the paper, and thank you everyone for watching the videos. If you have any questions, please let me know in the comments below, and good luck in your exams.